Hello and welcome. I'm Saeed from storyplanet.net. Dive right into the essence of the most captivating books without reading them cover to cover. Whether you're on the go, at the gym, or just relaxing at home, we offer you a unique and enriching listening experience. Today, we are exploring the book, Algorithms to Live By, a creation by Brian Christian and Tom Griffiths. Algorithms to Live By, 2016, is a practical and insightful manual that demonstrates the surprising relevance of algorithms in our everyday lives. It reveals how these tools can contribute to a more fulfilling existence, guiding us in problem-solving, decision-making, and increasing our productivity. Before we delve into these revelations, it's interesting to note that Brian Christian is a highly regarded author and speaker, known for his expertise in cognitive science. His impressive achievements include multiple awards and recognition from the Academy of American Poets. Besides being a contributor to esteemed publications such as The New Yorker, Wired, The Guardian, and various scientific journals, he also partners with Tom Griffiths. Tom Griffiths, an acclaimed professor in the field of cognitive science and psychology, heads the Computational Cognitive Science Lab at the University of Berkeley. His extensive body of work comprises over 150 scientific papers. With 10 key ideas to unveil, brace yourself for a deep dive into this captivating book. On storyplanet.net. To start, the text suggests using algorithms in your own life to benefit from them. Algorithms are not just used in computers, they also play a role in human thinking and decision-making. When our own algorithms fail, we can turn to computer algorithms for help. This book explains how algorithms can help in various areas of life, such as dating, organizing books, and decluttering. Key idea number 1. Algorithms aid in problem-solving for both humans and computers. Algorithms are a series of steps used to solve problems and can be traced back thousands of years. They are used in everyday tasks such as cooking and decision-making. Humans use intuitive algorithms, which are subjective and imprecise, while computers use mathematical algorithms. Both provide solutions to problems. Key idea number 2. Algorithms help us know when to stop taking risks. The optimal stopping algorithm helps in decision-making when faced with multiple options. It suggests looking at the first 37 options without making a choice, establishing standards, and then choosing the first option that meets those standards. This strategy increases the odds of getting the best outcome. However, it is not always applicable, as demonstrated by the example of a coin flip using the triple or nothing strategy. Pure mathematics would suggest continuing to bet, but eventually you would lose everything. Key idea number 3. Mathematical algorithms can assist in determining the optimal time to explore new things. The text discusses the concept of multi-armed bandit problems, which can be applied to situations such as gambling, dating, and investing. The stay-win, lose-shift strategy of sticking with a slot machine while winning and switching when losing is a simple approach but may not be the best. The upper confidence-bound algorithm offers a better method by choosing the machine with the highest expected value and tracking real outcomes to determine if a change is needed. The pharmaceutical industry's adaptive clinical trials also provide inspiration for solving multi-armed bandit problems by continuously evaluating and making changes based on new information. Key idea number 4. Algorithms can assist in organizing and sorting files when needed. If you prefer organized chaos, don't worry about always keeping everything neat. The main reason for organizing is to easily find what you need. However, if you want to sort things better, there are algorithms for this. The least efficient is the bubble sort, organizing one pair at a time. A better option is the insertion sort, where you put each item back in the right place one by one. For massive collections, the merge sort method is recommended by dividing, sorting, and then merging the piles together. Key idea number 5. Computers can teach us valuable lessons in organizing data. Computers store data in hard disk drives or solid-state drives. SSDs are faster at retrieving data, but hard drives can store more. Many devices use a combination of both. The most frequently used information is stored in the cache, which is accessed the quickest. The cache uses the least recently used (LRU) algorithm to determine what gets stored. This algorithm also works well for organizing physical items like bills and letters on your desk. Our brains work similarly, as information that goes unused for a long time is harder to remember. Reading notes before bed can make them more easily accessible in the morning. Key idea number 6. Algorithms are useful for scheduling, but they have limitations. Key points: to improve productivity, it is important to organize both files and time. Various algorithms, such as earliest due date and Moore's algorithm, can help with scheduling tasks. Beware of priority inversion, where less important tasks consume all your time and prevent important tasks from being completed. Time management solutions are not quick fixes and require effort. Focusing on one task at a time and ignoring distractions, such as emails, can significantly improve productivity. Don't worry about the length of your to-do list. Tasks will get done in due time. Key idea number 7. Algorithms can be used to make accurate predictions about the future. In this text, the author discusses the concept of predicting probable outcomes using algorithms. They explain how this idea originated with Reverend Thomas Bayes in the 18th century. They also provide an example of applying Bayes' logic to understanding the likelihood of winning scratch tickets. The author emphasizes the importance of collecting more information to make more precise predictions. Additionally, they mention the significance of understanding distribution patterns, such as the normal distribution or the power law distribution, when making predictions. An example of the power law distribution is the distribution of wealth in society. Key idea number 8. Algorithms are useful for managing communication and data overload. Computer scientists have come up with algorithms to ensure safe message delivery. One is called retransmitted till breakdown, where messages are sent repeatedly until one gets through without being captured. Another method is exponential backoff, where waiting time is doubled if there are server errors. The best solution is AIMD, which determines the network's maximum capacity by gradually increasing data sent until overload, then finding the limit and adjusting subsequent packages accordingly. Key idea number 9. Algorithms can predict and guide people's decisions by analyzing their behavior. The text discusses the concept of the prisoner's dilemma, which explores how rational individuals would respond to a situation where they have to make choices based on self-interest. In the example given, both prisoners are likely to turn on each other, resulting in a 5-year sentence for each. The text also mentions mechanism design, where incentives are used to encourage desired behavior. The example given is that of employers trying to get employees to take their vacation time, with the solution being to make vacations mandatory. The text concludes by mentioning that algorithms have applications in various fields and briefly mentions the limitations of algorithms. Key idea number 10. Algorithms have limitations that should be acknowledged. When developing complex models, it is important to consider multiple factors. However, overly complex models can be problematic and lead to overfitting. Overfitting occurs when a model is too closely adapted to specific data and loses flexibility when applied to new data. It is important to recognize that perfect algorithms do not exist and aim for good enough solutions instead. Relaxing standards can lead to efficient solutions in a reasonable time. Understanding the limits and possibilities of algorithms allows for their application in various areas of life. In conclusion, algorithms are not just for mathematicians and computers. We use them every day, and they can help us make good decisions and be more productive. One actionable piece of advice is to do the simple tasks first. Use the shortest processing time algorithm by listing tasks in order of what can be done the fastest. This allows you to get lots of things done quickly. Thank you for listening to this summary. If you enjoyed this exploration, we invite you to discover other fascinating books on storyplanet.net. Don't wait any longer. A multitude of books, stories, and knowledge await you there. See you soon on storyplanet.net.